You've heard AM, you've heard FM. Now, tune into DM Radio, the world's longest running show about data. Each week, host Eric Kavanaugh interviews the brightest minds in the world of information management. Want to be on the show? Send an email to info@dmradio.biz. Now, here's your host, Eric Kavanaugh.
All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanaugh here, and we have a very special show for you today, folks. A lot of times we talk to vendors and industry analysts and consultants, but once in a while we get the end users. We get the people who are on the front lines using all these technologies to come on the show and talk about what they do and how it all works. And those are often the most dense and interesting conversations because these folks have to hack away at the real world and get things done. And today I'm very excited. We have Craig Katz with us. He is the Director of Infrastructure Platforms at Discover Financial Services. So serious stuff. Discover's financial services industry, of course, or company, and that industry is highly regulated. So these folks have to worry about regulations and, of course, customer service and getting the job done. And it's money. So we don't want to screw up where the money goes and tracking where the money goes. And obviously, the fintech revolution is just taking the world by storm. The last, I would say, 5 years or so, we have seen tremendous innovation in the payments industry and in fintech in general. In fact, we have new terms like FinOps and RevOps and things of this nature that people are throwing around. And the reason for that is because we're seeing so much innovation in the financial services space. You know, the example I often give is when you used to Western Union money across the country to your kids at school or whatever, you'd pay $10, $25 sometimes just to send money across the country. Well, now you can do that with any number of apps for no charge at all. So that's a pretty significant change. And what we're seeing is the maturation of an industry, a maturation of the systems that run financial services companies. And that means better service for you and me, less fees, ideally, for moving money around, and a more seamless world of financial services. Nothing wrong with that. So with that, Craig Katz, welcome to DM Radio. Tell us a bit about yourself and this wonderful program called Trident that you folks have been working on for some time now.
So I'm Craig Katz. I'm a Director of Infrastructure Platforms at Discover. You're probably familiar with the credit cards, but Discover is a bank, as you mentioned earlier, a highly regulated industry in the banking area. And for the last several years at Discover, I have been involved in our enterprise level CI/CD pipeline, which we refer to as Trident.
Let's talk about CI/CD. That stands for continuous integration, right? Continuous deployments, right? Mm-hmm. And so you're constantly changing the software. Just to explain to our audience, the traditional way of delivering applications was done using something called waterfall. And the waterfall approach took a lot of time. You did a lot of requirements gathering. The developers went off and they did their development. They built something like an MVP, minimal viable product, basically. And then they throw it over the wall to the business and say, okay, guys, play around with this and see what you think. And that took months to do anything significant. So any new major feature would take months, sometimes longer than that. Whereas with CI/CD now, we have a continuous operation where you're adding and changing code all the time on a regular basis, right? Can you talk about just the significance between that old world way of doing things and CI/CD?
Yeah, and Eric, there's so much to dig into with that, but I'll try to keep it on the surface. And yes, when you're trying to release software to customers, you need to go through the following stages. You need to define what you're trying to do. You need to code it. You need to test it. You need to release it. And whether you're waterfall or whether you're agile, like those items still fall into place. So what CI/CD is intending to do is to try to take away one of the biggest complications with software delivery, and that's making everything into small incremental deliveries. It's better, to do 10 little steps than one big one, and for a variety of reasons. So when you're when you're building something really big that you might have one finite little error in the middle, but with this big thing, it might take a long time to diagnose it. If you're doing incremental releases, you can start seeing where stuff breaks. Also, small incremental releases can also give you the opportunity to get faster feedback loops, because what if you're building the wrong product?
Right.
Well, you don't want to take, if you can find that out within a week as opposed to a month or a year, then you're able to like take advantage of that feedback and pivot more quickly. So there's a lot of good reasons for incremental delivery. So easier to debug, easier to isolate, allows you to get feedback and react to it faster. Those are all good reasons. But another part of it too is small incremental releases. Like say there's a big mistake and you need to roll it back. Well, if you've introduced 10 big features at once,
Right.
and one of those might have like a hard business date, then maybe you can't roll it back, because you're hitting a date or meeting a customer approach or something like that. So all those things kind of factor into the idea that it's easier to ensure your quality and delivery on a bunch of little things than one big thing. So that's kind of like the C in CI/CD: continuous integration, continuous delivery.
Right.
So in the agile world, although you could do this in waterfall too, but the whole point is every time you're committing to your code repo, whether you're working on a branch or merging it into a branch, just leveraging automation to do the things you need to do to ensure that you're confident your code is release ready. So being able to run code scans, security scans, that type of stuff. So at Discover in Trident, like the first things we do are static code analysis, where it's going to scan your repo. We use tools that test things like duplicated code blocks or potential like vulnerabilities for things like SQL injection, as well as just kind of consistency. So there's tools out there that grade the style of your code, which is handy. It makes stuff more readable, more efficient. It also like gives you a bunch of feedback in a variety of ways. Like you're using too many parameters in this. It's, oversimplified. They're like, I believe that's called cognitive complexity.
Oh, interesting.
A bunch of generalized code guides that it can go against. And then we also scan for security. So at Discover, primarily we're, a Java shop, which has a lot of open source libraries that we depend upon. And we want to scan those libraries for security flaws because A, security flaws are bad,
Right.
and B, security flaws are extra bad when you're being regulated by the government, which the financial industry is. So those are the couple of things that we start with our pipeline. So it does that kind of scanning. And then as part of our pipeline as well, we kind of encourage, but we also expect that application teams are writing tests specific to this application. So if I'm writing a calculator application, I not only want to make sure that my code is formatted right and I'm not doing, including any vulnerabilities like I mentioned before, but does 2 + 2 really equal 4? Like, what about 16 divided by 4? Whatever tests you need kind of end to end. And that can take, those are what we call like those are what we call regression tests. You can have integration tests that test the connectivity between upstream and downstream applications. We have contract testing where you make sure that the interfaces are compatible between consumers and subscribers. Performance testing to make sure that your application can run under load. And that is not a one size fits all. These are things that need to be written around each specific application.
Right. Yeah. And just let's kind of get into that real quick, because if you think about this revolution I'm talking about in fintech and FinOps and RevOps and all these different things, there's tremendous value that can be gained by analyzing your data. And so as a consumer, I'm starting to see the front end of this. And I think it's very interesting because big banks, of course, have been using analytics for a long time to understand where the money comes from, where the profit comes from, where their expenses are, what the operations cost. All these things are what banks will do internally. But customers want to do that kind of stuff too. And customers want to have more flexibility to understand their projections. You're seeing some of the bigger banks do these things, which I think is very interesting. It's going to be, I think, a real next wave of applications. And in fact, just to pick one, and I'm not sure if Discover is doing this or not, but I noticed that one of the other big banks that I use is now allowing you to really challenge charges, and instead of having to go through to the streaming service or to whatever service it was that I bought this from, because there are so many now that are out there, they're actually killing the application for me. I said, look, I tried to get rid of this and I couldn't. I won't tell you what it was, but I mean, that's a pretty big leap in terms of functionality to suddenly have this intermediary, which is the bank, acting on your behalf to cancel subscription services. Can you just talk generally about the importance of enabling new functionality for your customers, which is, of course, what you guys are working on?
Yeah, it's well, with any business, like you've got to not only attract new customers, but you've got to retain the ones you have. And
Right.
these are things that in today's society, or in recent society, like we didn't have this kind of 10, 15 years ago with all the subscriptions and your information getting sold, or, the trial offers that are accessible over the internet. So it's just a feedback and reaction to where customers are today. And as a bank, like if you're spending, if you're spending less money on streaming, then maybe you're making more impactful purchases that can give us more information about the other products we have that can offer you. So it's like if you're buying a home, maybe you're interested in our home loan project, or if you're like other things like that, all that kind of fits into the picture of what a customer is and needs and how a bank can fulfill that. So keeping up with features like that, whether you're piloting them or copying them from a competitor, it's the kind of thing that's continually raising the bar. And that's, if you talk about fintechs, which you were kind of mentioning earlier, it's kind of a feedback loop as well. Is they're coming in and looking at what big established banks are doing today, and maybe they don't have the deposit reserves or the established credit card base like somebody like Discover does, but They can offer other things on top of it, and then so they start to offer that to customers, and then that's something that other big banks can say, we're seeing good adoption here, let's test it out with our group.
Yeah, and that testing is really important. So your Trident system is really your application development platform for designing applications and deploying them. And Trident does a whole bunch of great stuff automatically. You talked about the tests, and your teams, the app teams do have to come up with their own tests, but then they deploy them into Trident, and Trident will automatically do all that scanning. So basically, you're embracing both shift left and shift right, I guess, at the same time. The shift left where you check more before deployment, shift right is checking a lot after deployment, as I understand it correctly. But you're trying to encompass all of that, right?
I've never really heard the shift right before. We're totally shifting left, but we're also trying to go faster. But the key to all of this, and whether you're talking about the waterfall school approach that we were chatting about at the beginning, or what a company with a CI/CD pipeline is doing, is the question of engineering teams or product teams need to know what it takes for them to feel comfortable that they're release ready.
Interesting.
And if you know that and you can automate that, then you can release more often. And that's where the break from the old style of doing stuff is, having kind of the, industry history, like this got built up over time,
right?
Is everybody knows that automating all the things is good. It means people have more time to use their brain power and solve real problems, as opposed to, kind of grinding their way through, commodity type issues. And back in the day, and I remember this in my career, releases were a grind. You got to remember to do steps 1 through 30 and then check items 40 through 55 and this and that. It was just a bunch of things we need to remember, and that doesn't add value. It's what differentiates the software going through Trident at Discover is what our product teams have envisioned and our engineers have delivered that makes Discover's customers better. Like, yes, Discover customers can't use the code unless it gets released, but the act of releasing isn't something that defines Discover from any other software company.
Right. No, that's very interesting. And I love the term you used about confidence, having confidence to deploy, because you can always miss something, no matter how much you automate, no matter how much you look and examine, you can always miss something. And that's why you want to be able to roll it back. And you were talking about how the CI/CD environment really focuses on incremental changes, small changes. And I think in the next segment, we'll talk in more detail about Kubernetes and what a big deal that is and how it has spurred this whole industry of observability. Quite frankly, there are just dozens of companies now, whereas before there were a few. So clearly something is happening. And, from my perspective, that's what we see and what we try to watch and understand is the movement in the software development industry and what that means for end users using products and services, et cetera. We try to kind of sit in the middle of all that. But this incremental approach, to your point, it helps build in guardrails, and it also ideally helps expedite time to value from idea to creation, right?
Absolutely. And it's, and feedback cycles are important in all facets of stuff, whether it's product development, whether it's, software delivery, or I remember teaching my kids how to ride a bike. It's like, first you let them glide downhill on a bike with no pedals, and eventually you learn the other stuff. It's all about, that's how people work and how people work their best. As we said, the goal is to release high quality software quickly to our customers. I forgot a couple adjectives. Thanks for reminding me. So, that's the point of what a pipeline is meant to do, and to continue to make that cycle, faster and more comprehensive.
Yeah, and we'll talk about this in the next segment, but what Craig was telling me before the show is that their CI/CD pipeline supports both their traditional app development and deployment technologies or platform and also Kubernetes. And this is very interesting because all these companies that have been around for a while, they have legacy infrastructure, they have legacy processes, they have a code base, and that's a lot to understand and to manage, quite frankly. And now we've got these large language models coming out and all this AI is coming out, and lots of companies want to be able to leverage those kinds of things, but you can't leverage it very well unless you have a well understood, robust platform to use for rolling these technologies out. And that's what the folks at Discover have done, which I find to be very sensible, quite frankly, because you want to be able to be focused on the future while also serving everything that is extant, everything that's running your company right now. And I got to use my one of my favorite jokes on a show the other day. I'll do this as we go into break, Craig. The joke was, what's the definition of legacy software? And the answer is any software in production. The moment it goes into production, it is legacy software. It doesn't have to be 40 years old or 30 or 20 or 10. The moment it's out there running, you are on the hook for it, and you better make sure you can manage it effectively. But we'll be right back, folks. Don't touch that dial. You're listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
Folks, back here on DM Radio, talking to Craig Katz of Discover Financial Services, all about continuous integration, continuous delivery. I think I said deployment earlier. Technically, I think it's delivery. But it's a really fascinating and major shift in how enterprise software is designed and deployed and managed over time. And we've hinted at Kubernetes a couple of times just to remind our listening audience out there. Kubernetes is a project. It was, I think, run through the Apache Software Foundation, and it was a Google project, open source technology, and it sat on top of Docker. It sits on top of Docker, and Docker was really kind of the beginning, and then Kubernetes won the battle. I've been told, one of the theories I heard I thought was kind of funny is that Kubernetes won because developers typically don't want to pay for anything, and Kubernetes is free. And so what you do is it's container orchestration, and the best description I've heard to define what it really boils down to is distributed compute and little system processes, basically. So I'll define, or I'll use the metaphor of a spell check. That would be a pretty gritty process, but you can use a spell check in a word processing application, or a spreadsheet, or some design application. You can call it for any number of types of applications that need that service. So you don't have to build a separate one for each app, basically. And that's the general idea. And that you figure that's what an operating system does, right? Is it has various functions that are called upon by applications to do stuff, to build applications and to make stuff work. So it's much more ephemeral. These little containers are small and they can just arise and do what they need to do and go away. That happens all the time. But it is a much different way of designing software. And so, Craig, you were saying that your pipeline, your CI/CD pipeline, is designed to enable the development of applications and the testing and so forth for them. And then when you've done that, you can either compile it for Kubernetes or compile it for a traditional environment. Is that right?
Yeah. So in our traditional environment, we just need to compile the artifact. In our Kubernetes environment that we're pivoting to, you have to containerize, with that application and then hang on to that image. But it's kind of one of the repeating topics I always come up with is, iterative development. So the idea of what it takes to adopt automation in your pipeline is, an amount of work. We talked about, I think, like 5 or 6 different types of, test suites that you're going to need to do to have confidence in your application. So integration, contract, performance, et cetera. So, and if you're in an industry or in a company that hasn't put that kind of diligence and work into it, that takes time. You might have to rework your application so it is testable, which is kind of like a dimension that wasn't necessarily like a big focus for engineers, 15 or more years ago. And to a degree, it kind of pervades. Everybody runs into deadlines. In the short term, it's a lot faster to just rip something out than to kind of, break it down and test all the individual parts. But the thing is, it's an investment, because then every other time you revisit it, you've got the confidence because you got the tests in place to lock everything up. I like to say that unit testing, where you're testing like just individual methods or whatnot, it doesn't mean that your software works the way you want it to. What it does, though, is it protects future you from making mistakes. So you can thank yourself later. But yes, we did decide.
You can thank yourself later. Hold on, that's a quote.
We did decide, though, because that is a layer of investment that we needed application development teams to put in, is that instead of having them try to do all this on a pipeline, to get it and deploy it to a new environment, it's just way too big an iteration. So we put in the support where they could break that up, start imbuing the quality on their current platform, our legacy platform, while allowing the support to either subsequently or simultaneously deploy to our new environment. So you basically don't have your new code sitting on a shelf as it continues to diverge from your existing code base. Again, you want to keep everything current. I did like your comment about it's legacy software as soon as it gets out there. Well, waiting for new software and keeping it in sync with legacy just adds a lot more complication.
Sure.
So the approach to be able to code, define, and deploy simultaneously just made sense.
Yeah, that's a brilliant approach, I have to say, because you're right. If you have these two divergent tracks, I often refer to it as high-speed trains that are in slightly separate tracks, and pretty quickly it's going to break apart, and anything that was trying to hold on to both those worlds is going to break, basically, and that's not going to be good. And let me ask you this: the form factors are so important these days, and you talk about designing for Kubernetes or different sorts of deployment. I'm guessing that you have to keep in mind form factors like browsers, and when browsers change, the different devices like the new iPhones, the Samsungs, things of this nature. How big a part of your day is it worrying about that kind of thing with the testing, the automated testing on all these different endpoints, and how do you guys manage that?
So for better or for worse, that's not a problem I specifically have to deal with in my current role on the infrastructure end. But I've been through in a lot of application development areas over the course of my career, and spent some time at Discover working with the mobile app. And one of the things we did was, we talk about these test suites. We had, for the Discover mobile app, which is the #1 point of entry for all Discover companies, and we had around 2,000 automated tests that we had to run against 4 separate form factors. So iPhone, Apple tablet, or iPhone, iPad, Android phone, and Android tablets. As well as kind of, we did a randomization within that to hit the different subspecies within them. So one of the interesting things about testing automation is, time. If we tested everything for every application, that takes a lot of time, and it defers launch. So speed to market is important. So the question is, if you do a random assortment, like instead of doing just iPhones, if we just do the current and the N-1, and we did every other test in that, then how good do we feel? And maybe if we throw in like 1/5 of that, to be like, N-2, these are approaches that you kind of have to work in with testing. And we do have a software vendor that emulates all these different, they emulate, or they have physical versions of all these that we can run our tests against. And then you try to run them all in parallel, but it still takes several hours. Yeah. But the goal is, but the improvement is, when we used to have a team of testers, it would take 3 weeks. So we did drop it from, 21 days to half a day.
Wow. And that's such a huge deal, because you think about it, you in this environment with Trident and the infrastructure and the app delivery platform, you're sitting in between what the customers experience and what corporate wants done, basically. So corporate has various objectives. We want to improve our closing percentage, for example. There are all sorts of things that could be done. 360-degree view of the customer, right? There's all this external data that can be used these days, borrowed, whether it's location data or preference data. I mean, there's just all kinds of stuff that you can use these days to better understand, A, your customer, but B, what ideas might work and what ideas might not work, and to shorten that time to discovery, if you will, the time to play around with things in a sandbox and then just try them. That's hugely important to enable enterprise agility, right?
Yeah, absolutely. It's, key for, getting the information, and are you on track with where you need to go? And on top of that, what you were also saying is, also, again, discovers a bank. So it's like, not only are there features and different ratios we want to hit for making money, but there's also a lot of compliance involved too. Right. So if regulations come through that we need to track this, or disclaim to people this, or have them consent to that, those are also things that we need to get through, with the same level of speed and accuracy.
Yeah. Well, and I noticed that some of the stats that you were touting with Trident are pretty darn impressive. Apps are deploying 90% faster. Speed to market went from 2 weeks to a day. I mean, that's exactly what we're talking about. What you think about, cycle times, you think about sprints, right? That's a big concept in development. All right, 2-week sprints. We're all going to go and figure something out and come back and see, did we figure this out, et cetera. Well, when you can collapse 2 weeks down to, let's say, even 3 days, that's a big change. And that kind of helps you prioritize and then speak back to the business about what's possible. Because you'll have this whole wish list of things that need to get done. You'll have, of course, the mandated things that must get done, stuff like security, governance, et cetera. And as a developer, I'm going to throw this fun one at you. One of my best friends is a developer, and he has this great line, this mantra, where he says, busy is the enemy of creative, which I find fascinating, because if you're busy all the time, and I've got another guy in my media business who once used this term that just gave me the shivers. I'll never forget. He referred to the tyranny of urgency. When you're behind the 8 ball and you're just constantly trying to stay up and just reach the water level to get some air, that's not a good place to be. One of my other buddies calls it code red. You don't want to be in code red wherever you go, because it's just stressful as hell. And so what you're able to do here is really open up a lot of white space for trying new things and for seeing what works and being able to measure what works. So it's just a much different environment. And I have to think that's much better for morale of the team. What do you think?
Yeah, it's as I like to describe it, it's you're removing commodity work. So things that don't require specialization, if we can automate that down, abstract it away, and whether we do or don't feel better about it, but we do, is that opens up some of that white space. And yes, like in a, enterprise, you're going to have like some of the things that fill in the white space. Is this an opportunity to optimize staffing levels? Is this an opportunity to put more stuff on the back end going through? But it does give you the kind of burst ability that when you go through the point where maybe you had an inspiration of a product and you get the engineers to code it, then you don't have to sit in a holding pattern for weeks while it's thoroughly tested to get that confidence that we need. And then God forbid, if somewhere in that testing cycle you find a problem, then you've got to go through and either wait for the stuff that's in flight now or kick that stuff out, which again, context switching is, maybe it's not as bad as being code red busy, but it's also just another thing that eats away at the ability for people to get stuff done.
Yeah, and that's a really interesting component too. And this is why I talk about morale and really the psychology of development. And then you look at again some of these newer tools that are coming out, some of these large language models. I remember when I first started playing around with them, it dawned on me like, if they can write in English and German and French and Dutch, I bet they can write in Java and HTML and COBOL. And the short answer is, yeah, they can. And it's not perfect yet. That's what I've heard from lots of people who are playing around with it. But still, it can kind of expedite the process, and you can get some working code at least to kind of play around with. It can give you 80%. And then the other thing that companies are talking about doing is using these LLMs for decoding and for basically, you can put the code into this LLM and say, what is this doing? It'll come back and give you some explanation. Well, you probably know as well as I do, most developers don't like to document what they do. They like developing and doing cool things. And so a lot of the platforms are now kind of handling the documentation for them automatically, which gets us back to automation. But what do you think real quick about this new evolving era of large language models and AI infused code development?
No, I think it's just one of those things that we're all going to have to adapt to. And, what I've been kind of seeing as I went, with the places I browse the internet is everybody's worried about like, oh, automation, AI is going to take away jobs. And, customer service and software development and, various other industries. But automation, like people always fill the void, kind of as you were talking earlier. So people are going to find other things to do with their time. And there's tons of examples of that throughout history. As when you automated the assembly line for cars, then they got more feature rich and more performant and safety went up and all that. I'm sure there are better examples than that one.
That's a good one though. No, that's a good one.
But I do find it interesting that I hear casually. In fact, I had a relative over last night who said the same thing. AI is going to be taking away my job in, the next couple of years, and he does film editing. And I'm like, okay, you'll find something else. And he felt the same way.
Yeah, film editing, I can tell you, is very painful to do it manually. I've done it, and it's brutal. It is just not fun at all. And it was actually a couple of years ago on, I think, my iPhone or one of my devices that it automatically grabbed a handful of pictures and threw some music behind it and threw this thing out there, and it was pretty darn good. I was like, wow, that's a pretty neat little video of stuff that we've had. But listen, Craig, it's so much fun to talk to you about all this. Look this gentleman up online, Craig Katz from Discover Financial Services, and learn about Trident and why Discover is able to do things a lot faster than other companies. We'll be right back. You're listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, welcome back here on DM Radio. Your host here, Eric Kavanaugh. What a fantastic conversation we just had with Craig Katz from Discover Financial Services, talking all about Trident, which is their CI/CD pipeline, as it's often described. Really, it's their application delivery platform. So how they design new applications, how they bring new functionality to their website, to their mobile devices, et cetera. That's how they're dealing with it. And I thought it was very clever that they have this fork, basically. So they have a CI/CD pipeline, and then at the end of that, you determine, do I want to run this in my traditional environment, or do I want to run this in a Kubernetes environment? And that is a very effective way to enable this next generation. So we've talked about Kubernetes many times on this show, and you heard Craig mention technology.discover.com, which is where they have a whole bunch of information about their programs and how they operate and what their values are. And they talked about their commitment to open source. And this is a very, very big deal. So I've been studying open source now for the past, almost 20 years. It was about 19 or 18 years ago that I began in earnest my research into this space. And back then in 2005, I remember learning that the Apache web server had passed Microsoft's web server as the #1 web server on the internet. So remember, web servers were what would host websites and deal with all the interaction between users and browsers and websites that various people would build. You need a web server to host those things. And that was the first major project that came out of Apache, the Apache Software Foundation. Well, open source really started with Linux. I think most people would agree with that. Linus Torvalds decided he was going to build some open source platform. And the timing was actually quite remarkable. Now, I've been told by insiders that the proliferation of Microsoft operating systems was not the main driver behind the design and development of Linux, at least at first, but it wound up being a very fertile ground. So if you think back, if you're old enough like me to remember, in the 1990s and the early 2000s, you would still buy software and it would be on CD-ROMs, and you would stick that into your driver and you would load your software, and then you'd be off to the races with some new software. Of course, you would load your operating system with CDs, or back in the day, floppy disks, for crying out loud. Well, this open source movement really changed a lot of how things are done. And what I find so impressive is that in the open source world, which is now largely web-based, you have this reality where the foundations are all agreed upon. So that allows you to move away from this reality of everyone reinventing the wheel all the time for their own environments. And that's really what software companies have been doing for a long time, for many, many years, is you would have everyone building their own. So in the Microsoft example, you'd load your software and you would choose from the operating systems. And I don't know if you remember, but you would have like the Apple operating system, maybe Linux, and then 14 different flavors of Microsoft Enterprise, Microsoft Server, all these different versions of operating systems. Well, that's a real pain in the neck for developers, because there are different little idiosyncrasies to the different platforms, to the different operating systems, to different OSs. Basically, there are just different aspects to it that have to be considered and tested for, and woven into the fabric of your design. And that was a real pain. And so what happened in the enterprise world is that large organizations started looking to Linux, and IBM played a big role here. IBM stepped in, and I'm told, and spent $1 billion hardening Linux to make it an enterprise-grade operating system, just like Microsoft, or of course, Unix is what I think it was based on. And Unix has been around for a long time as well. And Unix was a very durable operating system. One of my techie friends 20 odd years ago would tell me stories about Unix applications that would be running for years and never have to be restarted, never had any kind of problems at all. Well, that was in the old days. In the old days, you had to be a lot more careful about code and how much code you have and how much code you use and develop, because the processors were very slow. And so you had to be very careful with your code. It had to be very clean and very lean. And of course, it was very expensive to do this stuff. So those were the old days. And then as the operating systems got more complex, and as the processors got faster and faster, you had something called code bloat. And code bloat simply said that developers got a little bit lazy, because they could write a lot more complex code and still have it work efficiently because of the processors were so fast. Well, there's always going to be this sort of tug of war between these worlds of, yes, we can do things faster, but does that mean we have to be less efficient? I mean, you should always be more efficient if you can, but it just depends on, what operating system you use, or I should say what software you're using. If you're a Java house, you heard Craig say that they do a lot of Java in their organization. Python, of course, is becoming very prominent in the world of enterprise software development, but so is C++, so is C#. I mean, I heard a great story about a company that looked at Apache Kafka and said, hey, we can do a much better job at that. That company is called Red Panda. They went out and built what is essentially Kafka using C++, is my understanding, and it's a lot more efficient. It costs less once it's deployed, and theoretically, you can add more features to it. So, but my point here is that there are all these different dynamics that you have to keep in mind when you are deploying your applications, when you're building out your teams, right? So you think about Craig's example with Trident and what they're doing at Discover Financial Services. They've really thought through the end-to-end process, and they've built this platform and have been really optimizing this platform for quite some time now, last few years, I guess, to optimize the delivery and the security and the governance and the efficacy of these technologies. And you can kind of see it out there. You can see it in the real world when you get new features on your phone for some app, like your Discover app, let's say. When those new features come out, folks like Craig were involved in the whole process leading up to that, leading up to helping people figure out how to get these things done. And the faster you can change in the modern world, I can tell you right now, the faster and the better you're going to do. So I was encouraged to hear this promotion of open source and this commitment to open source, because now open source has climbed up the stack. It's no longer just on the web server side, for example. It's no longer just the operating system. It's now a whole bunch of other technologies in the data space in particular. Of course, Hadoop was an open source project, and many lessons were learned over the years of Hadoop deployments. We're now not really looking at that so much, in part because cloud storage costs came down. One of the value propositions for Hadoop was that you could have very cheap storage, but guess what? Cloud storage caught up. And so that sort of pulled the rug out from part of the value proposition for Hadoop, and also just wasn't a very efficient way of working with data, quite frankly. But Apache Spark is another open source project. And of course, Databricks has led that charge. And Databricks has been on a tear lately. Databricks, you probably heard, bought Mosaic ML for $1.3 billion. Databricks announced their own vector database. We've been talking about those with reference to large language models, for example. And Databricks even solved this whole challenge of should it be Iceberg or Delta Lake or Hootie? Well, all three of those use Parquet as the file format. And so some clever people at Databricks figured out that they can unify that part of the stack. And again, this is a crucial time in the industry and a crucial technology component in the modern data stack. And Databricks figured out that if they just look at the Parquet files underneath, they can enable you to choose whichever one you want. If you want to use Hootie, good for you. Delta Lake, good for you. Iceberg, good for you. There's a lot of momentum. There's a lot of push behind Iceberg, and to look all this stuff up online, folks. Check out on Wikipedia. You'll find, of course, Apache has all sorts of information about it as well. But I'm very encouraged to hear this commitment from Discover to open source, because guess what? Open source, it needs developers, it needs committers, it needs people who maintain these projects and stay on top of these projects. You know, Craig kind of hinted at it a couple of times that you really have to constantly be paying attention to your environment, to what's happening in the marketplace, to what your competitors are doing, and you have to be able, ready, and willing to make sure your code is going to get the job done. And that is a moving target. It's a target that's fast moving, quite frankly. There are other things in the offing that are going to have a pretty big impact. We don't know when exactly they're going to come to the fore, but we've talked about quantum computing and when that's going to happen. Now, some people kind of laugh at the quantum computing storyline because it's like AI. It's been touted before. It's been touted for quite some time, but still hasn't quite broken through into the mainstream. But guess what? It's going to. I think it's going to be probably in the next 2 or 3 years. And why is that a big deal? Well, one of the reasons why is because, according to some of the experts I've talked to, cryptography is going out the window. Typical ways of securing applications and environments, standardization that we've seen in that space, for example, is theoretically going to go out the window. So that may be why you're seeing such a huge push for two-factor authentication, because it is a guardrail, it's a backstop for security. Because if someone can do a deep fake that looks just like you and sounds just like you, well, then they can do a deep fake that can get through into your bank accounts or other things. And that's all in the offing. But folks, thanks so much for your time and attention. Send me an email, info@dmradio.biz. We want to know what you want to know. You have been listening to DM Radio.